Marine Laboratories Elizabeth Moore International Center for Coral Reef Research and Restoration presents our next topic of the week, which is ocean acidification. My name is Stephanie, and I work down here at our Summerlin Key facility in the Florida Keys, and we are very excited to be sharing this virtually with you all today. We will be sharing further content on the subject throughout this week, so if you guys found this via Facebook or YouTube, all of our content is also on our Google Classroom. This is truly a great source to check out all of our new and virtual content we have ready for you guys. So materials, pretty simple today. If you would like, you can break out a notebook and pencil and take some fun notes on ocean acidification. Or you are more than welcome to kick back, relax, and enjoy our presentation we prepared for you guys. So let's quickly go over our learning objectives for today. We hope each of you gain a basic understanding of what ocean acidification is, understanding the causes and effects of it, being able to understand the relationship between ocean acidification and our coral reefs, and also gain an understanding on Mote's research on the subject. So let's dive in and take a closer look. We hear this term all the time. Ocean acidification usually goes along with climate change, warming waters, so what truly is it? Ocean acidification is the reduction in the pH of the ocean over time as CO2 is absorbed. This means as atmospheric CO2 levels increase, so do our CO2 levels in the ocean. Our oceans are the largest carbon sink on Earth, which is a reservoir that accumulates and stores CO2 over a prolonged period of time. Half of the CO2 that has been put out by humans, the oceans have absorbed. As seawater absorbs CO2 from the atmosphere, numerous chemical reactions occur. CO2 reacts with water molecules, or H2O, and this forms carbonic acid, as you can see in this figure. This compound then breaks down into a hydrogen ion, H+, and bicarbonate. Hydrogen ions is what causes this decrease in pH, or acidifies the ocean. These hydrogen ions then compete with organisms for the carbonate ions, which some organisms need to build their calcium carbonate shells. Removal of these carbonate ions from the water makes it more difficult for organisms to form their calcium carbonate-based shells, and more energy is spent doing so. So let's think about what animals might utilize this. If you guessed corals, you are correct. Corals rely heavily on these building blocks to form their skeletons. Now, we already went over that CO2 ends up in our oceans from the atmosphere, so this is a great figure to better understand that. Observe the increase of CO2 in our atmosphere over the last 50 years or so. More human productivity equals an increase in CO2 in our atmosphere over time. As you can see in this chart, atmospheric CO2 levels drastically increased as a result of the Industrial Revolution. This is anthropogenic, which focuses on environmental pollutants due to human actions. This includes burning of fossil fuels in industries, usage of energy in homes, emissions from transportation sources, manufacturing, and deforestation. Let's take a close look at the top image from 1850. What do you notice? Looking at the ocean acidification pH scale, our oceans range from 8 to 8.3. Comparing this to the bottom image for the predicted pH levels, in 2100, there is a large variance. These numbers range from 8 all the way down to low levels of 7.6. That being said, the 2100 pH prediction will all depend on human activity in the future. If we are able to reduce CO2 emissions, these numbers may not be as extreme. If the temperature and chemistry of the ocean change drastically in the future, this will continue to gravely threaten our already endangered coral reefs. So to better understand ocean acidification and changing pH, we are going to take a closer look at this figure. This is a pH scale, which has a logarithmic scale of 0 to 14. The lower the number, the more acidic a solution is. 7 is neutral, and higher values are deemed more alkaline, also known as basic. So values less than 7 are acidic. So looking at this image, what is more acidic, bleach or an apple? If you guess apple, you are right. Now I want you guys to locate where 8.1 is on this scale. Today, the average pH of the ocean is 8.1. So what do you think will happen to the ecosystem if the pH continues to drop? Believe it or not, some organisms may thrive under these changes in pH, while others we are finding will severely be at risk. These images show a pre and post coral health in an experiment where coral was exposed to acid. Acid was placed directly on healthy coral under natural conditions to track the effects and simulate ocean acidification and the impacts on corals. The carbonate skeleton of the coral degenerates as a result of acidification. Now imagine this on a large scale in our oceans. And this brings us to our chaos system down here in Summerlin Key. It is used to mimic future ocean acidification and climate change scenarios by our staff and visiting researchers from all over the world. Our team is able to test corals of various genotypes, which is simply various DNA, in these predicted ocean pH and temperatures in our chaos system. By doing so, we can identify which genotypes of corals are most resilient and can survive in said conditions. Identifying coral genotypes which are resilient to low pH and or high temperature will aid in restoration and outplanting corals that have a better chance at survival in the future. We can't stop ocean acidification entirely as a whole, but humans can make some adjustments that can improve the health of our oceans. This includes reducing our carbon footprint, which we can do by decreasing the amount of fossil fuel that is burned. We can continue researching the subject, as well as utilizing and supporting sustainable industries. Renewable energy sources such as solar, wind, hydroelectric, geothermal, ocean, and biomass are all new and innovative options to keep in mind. So coming up this week, check out our home activity that will come out this Friday on this subject. This will be located on our Google Classroom. The class code is located right here, and feel free to shoot us an email at Keys Education with any questions. Thank you all again for joining us today. Also follow us on our social media at Protect Our Reefs, and we hope to see you all again soon.